Welcome back to Solvex Society. This will be the second episode of our Rust series where we are covering shadowing as a topic. So we'll pick up where we left off from the first video. I am in Rust episode of 1. So I'll just cd // I'll just check. Yeah, that's my directory. So I'll just write that same thing, cargo new and Rust ep2. This will create me my project. Guys, go into it. Let's cd. I'll do this. I'll pick up our Rust episode 2. The cd right into it. Right? Yeah. Let's see if I'm in the right place. I am. What I can do is command p Rust ep2 and I'm on the main. So let's get our first builds. I'll just check cargo toml. I do not need any dependencies for this. If I do cargo run, what will happen? It builds, it compiles, and it prints the value correctly. It's a macro, right? I'm writing let x. Well, otherwise I am very specific. I like to explicitly read out my types and my variables. So just for simplicity, understanding, I'll just keep it absolutely simple. So I will do let x. I have a variable x. I set it to an integer 5 value. Another one, let's say x equal to shadowing, right? And if I print the value of x, and I will be specific here, print ln testing, and I'll pass it x, right? I'll use cargo run, right? It's testing and shadowing. The basic concept of shadowing simply means that creating a new variable with the same name while old variable goes out of scope or becomes inaccessible. So I would want you to consider another thing. Let's say I'm writing x plus 1. So Chamkya, what is happening? We have set x as 5 and x is now x plus 1. What happens is that x here is now bound to the value 5. H's right hand side, right? Now a new variable is named x is created with the value 6. This is 6. Now the old x, correct, is no longer accessible. This allocate new heap memory. When we write this, what happens to the actual memory? Okay. I would want to note two things. 32 lives on the stack. Right? And so no heap allocation occurs here. So Shankya, please perks out. What about heap allocated types like string? Heap allocated types is the default feature, right? And let's say let s equal to string from going to use from hello, right? Hello, and I'm going to do let s request. Is this shadowing? Yes, this is shadowing, but what happens? Does this allocate new memory? No, this does not. This does not. Ownership of string is now moved to the new s, right? The heap buffer containing hello, right, stays exactly where it is. Only the stack metadata, pointer length and capacity is moved. So what do I mean by that, Shankya? What does it mean? So simple, right? I'm going to visualize a stack here. It's just a visualization. So let's say I have a structure type of a stack, right? It has 3 things. Mostly, we all know what are the things stack will have, and those are pointer, length, and capacity. So this pointer used to point sides, which is the word hello, right? That is it. Now, since writing this line, right, a new pointer is made. With this, so old s is now invalid, right? Yes. Pointer changes, but value remains the same. This is very simple concept if you're coming from C++ background. Where does shadowing create a new heap allocation? To answer that, it's really simple. Only if the expression on the right hand side creates a new one. So currently we have that same s, right? Let's say it's now hello. Let s equal to s plus world. What happens now? It's very interesting. So now there's a certain memory required for hello. Obviously, world is now added and it will need a larger string to store. Right now, it may allocate a new heap buffer depending on the capacity it has. Right, and the old allocation is eventually freed. Now, with those basic understanding of stack, heap, and how they are working, I want to again reiterate some things and make it explicitly simple for you. Let's have a variable x equal to 5, x equal to 10, and if I print that, we do not modify this original variable. What we're doing is we're creating a new binding. How this is different from mutability or mutation, right? We'll basically use the same variable that's being used, but with shadowing, we're just changing the binding. So mutation changes a value. Shadowing creates a new binding. So I'll just write it. This is where shadowing becomes interesting. It starts to become technical from here on, right? So let's say spaces. This is an example I'm just taking. I think this is the same example in Rush book. So I say spaces dot length. What's happening with this? We are changing the type explicit, right? And what does this bear? So if I say print ln, I will make it a macro. If I just run again, I'll go run. And it says this. Don't worry, this is very common. You'll be doing most of these things again and again to get this right. Okay. Help if this is intentional, prefix with an underscore. Unused variable x. Is that all? Stack. Yeah. This was again an example. Anything that can break, I see. Should be good. Let the rest scores run. Right? Okay. See, it comes as 3. So it starts with str, pointer of string, and then it turns into a length, right? And this is basically the type of new size. So since this turns into a U size and the value becomes 3. What is U size? It's a primitive type which is basically it's a wildcard unsized integer. You can do this with shadowing, but you cannot do the same thing with mutable, right? So the main thing is mute is, again, it won't let you modify the type of the variable, right? So let's say mute spaces, and if I do spaces, try to make it, let's say, spaces dot some function. Change the name. Try to do this, maybe. This is mismatch tags. This is the error of mismatch tag, right? So that explains it, that mute will not let you change the type of the variable. This is one of the strongest examples, I believe, that can highlight the difference between shadowing and mutability and why shadowing is just so much more flexible. it can be. I'll try to be much more in detail about this one. Like say that name going to string shut. Let's see that. Right. Point is made Rust. Thank you. Save again. Make cargo run. See, L1 is taking the name Chunk, that property. Has should be heap. Must link list. This should be heap. Heap value is Shankya. This can involve a new heap allocation because to uppercase creates a new string. Now, this is an important distinction. Shadowing itself doesn't allocate memory. The expression used to create the new value may allocate new memory as a function. Right? We can go much deeper in there. Let me know. We can cover that. Now, this is an excellent example to prevent the common misconception. If I do this, I'll just do this. Right? What are we doing now? And we are not creating another Rust on the heap. Right? And we're moving ownership. Now, in stack, let's say, right? Old name. Try to highlight this correctly if I can. It and old name. The heap remains the same while the new name takes over and invalidates the old. Right? So the old binding is no longer accessible. So the heap allocation is reached. So I'll just show you the multiple transformations. So this will unlock a lot of things. So let's say get input. I'll have this, let's say 42. So we have taken a string value as input. We have passed it to the idea would to what we want is an i32 value, and I'm going to multiply it by 2. Right? It's simple. Let's print out and see what's happened. So again, I'll have print as a macro. So let's see. I'll run 84. Right? So what happens? How does this transformation work? So input goes through multiple transformations here, right? And so it's going through, let's say 42. 2 is going to be a string slice and str. String, right? It will go to since the unwrap, since we passed it, it will be now a value integer of a 32 value, and the next transformation we're just multiplying it and it's 34. That's it. So you can transform a value step by step while keeping the same meaningful variable name even when its type changes. So shadowing doesn't mean Rust is allocating new memory. Shadowing is about bindings, and whether memory gets created or allocated, let's say, completely depends on what you are doing to create the new value or what method you're using. Also, feel free to name the theme I'm using today on my VS Code. I will pin the correct one in the comments. Thanks again, and I'll see you on the next episode of Solvex Society Rust series, episode 3. So, summarizing this, I would say shadowing isn't Rust secretly moving things around in memory every time you reuse a variable name. It's simply Rust giving you a new binding with the same name. And that's actually what makes it powerful. You can take a value, transform it, even change its type, and keep the same meaningful name throughout the process. As your program evolves, that's a golden thing. And shadowing changes the binding. The operation determines what happens to the memory. Once you separate those two ideas, Rust's memory model starts becoming a lot less mysterious. That's really the mental model I want you to take away from this. Shadowing changes the bindings while the operation determines what happens to the memory. Once you start thinking about trust this way, a lot of things that initially feel confusing start to make a lot more sense. So if there's one thing I want you to remember from this episode, it's this: that shadowing isn't about creating some magical new memory every time you reuse a variable name. It's about creating a new binding. And honestly, that's one of those small Rust concepts that become really important once we start getting deeper into ownership and memory. If you're following along with this Rust journey, consider subscribing, because we're going from the fundamentals all the way into the deeper stuff. And we're learning it together. If you found this useful, hit the like button. It helps more people discover this series. But I especially want to hear from you. Drop a comment with the Rust concept you're struggling with right now. I'm actively reading the comments, and I'll do my best to reply and learn alongside you. Thanks for being here, and I'll see you in the next one.